Hello and welcome to the third episode of our Quarkus and LangChain series. In this series, we talk about how you connect ChatGPT and Hugging Face models to your Quarkus enterprise service. In our episode today, we want to look at Retrieval Augmented Generation. Retrieval Augmented Generation is a technique that can be used to enhance the context of a large language model with context-specific data. So data that you might have from within your company's data or data that is specific to a certain topic to help the large language model to produce a meaningful output instead of just guessing something or hallucinating something. How does this work? So, on the Quarkus LangChain documentation, we can see this nice image here, and this illustrates the process quite well. In the first step, we ingest our documents that we want to later use into some document store. To be precise, into a vector database. In this case here, they use Redis, which we will later also use because it's quite simple to use. But there are also other document stores or vector databases that you can use. So these documents are not just put into there, but they are indexed with a vector generated from an embedding model. The embedding model has a look of the content of this document and generates an embedding for it, so a vector in a high-dimensional room, and then we can later search for the relevant data. So when the user calls our system here, we first use the embedding model to create an embedding from the question of the user, from the prompt of the user. We retrieve all the relevant documents for this, and then we put the prompt and the documents together and send it to the large language model. And with that, the large language model has more relevant context, has more information it can work with, and can provide us a better response. Now that we have seen the high-level process, let's dive right into the project and have a look how it works in the code. I went ahead and prepared a bit our new AI service. This time we will have a Quarkus Documentations AI service. The idea is that this documentation bot will help us understand Quarkus documentation and can answer questions that we have about Quarkus. Specifically, today we want to make a bot that helps us with the LangChain extension. So what we have here is we register an AI service on our interface. We define a system message, which tells the bot it should behave as a coding assistant that helps us to get insights into the documentation, and we will provide a user message. Furthermore, we just have the simple method here. We provide a user ID to choose the right memory, and we provide the user's prompt. I've also went ahead and defined the resource, so we can call this. So the resource is under /Quarkus, where we have a simple get endpoint, and we can provide the user ID and prompt, like we did in the examples before. So let's start up the service and have a look how it works. So the service has started, so let's switch over to Postman and have a look. So I went ahead and already prepared the call. Here we just call the /Quarkus endpoint of the resource that I just showed you, and we provide a user ID to connect to our memory of this conversation, and we provide the prompt. So in this case, I just want to ask ChatGPT, how do I need to configure Quarkus to connect to LangChain and use ChatGPT? Let's see what ChatGPT comes up with. Okay, let's have a look at the response. What we get here is ChatGPT is talking about using Quarkus. That's quite good. It tells us how to set up a new project. And then it tells us to add the dependencies. But what does it add? It adds the standard REST client. And it also tells us that you might want to use a REST client extension to call an API because it knows ChatGPT offers an API. So it's giving us a rather generic response because the ChatGPT knowledge doesn't include the very new LangChain extension. So what ChatGPT did, it's used the knowledge it had and it learned from and tried to provide an answer for us. But of course, the new stuff is not in there. And also you might have your company internal specific data that might also not be public in the internet, and then ChatGPT will not know about it. That's exactly where RAG comes in, the Retrieval Augmented Generation, where we provide ChatGPT these documents. So let's have a look how we can do this. So first of all, we will need to add the extension that we can use as a vector database. As I've said before, Quarkus LangChain supports a couple of them. One of them is Redis. So we will add the Quarkus LangChain Redis extension here. This extension also automatically brings the Quarkus Redis extension with it. So we also automatically get the test containers so that when you have Docker running locally, you don't even need a Redis instance to begin with, but Quarkus will start one whenever you start the container in dev mode. One more thing that we need to adapt is in the config, we need to configure the test container image. Normally, the Quarkus test container for Redis is just a small Redis image, and it does not include the search extension. But we need the search extension to be able to make a vector search. So we need to change the test container image that we want to use. And we can just specify that as the dev service image name, we want to use the Redis stack image. Now we need to define another property, and that is the Redis dimension for the search index. So this dimension depends on the embedding model that you will be using. Since we are using OpenAI's ChatGPT right now, in our example, we will also use the embedding model from OpenAI automatically. You can also configure a different embedding model if you so wish. Importantly, the OpenAI embedding model has a vector output of this size, so we will just enter this value here. This is the value that you will get from the documentation of your embedding model. Let's have a look at how we can import these PDFs into our Redis store. I went ahead and prepared this already, so we can have a look at the code. So what we do is we just define a bean, and we first need to create an ingester, an embedding store ingester. And we can do this by first injecting a Redis embedding store and an embedding model. With the embedding store and the model, we can together combine this and use the builder from the embedding store ingester to build the ingester. And here we also need to provide a document splitter. The document splitter is used to split up the document, to be frank. And there is different implementations on how this can be done. The idea behind this is that if you have a very long document, then not the whole document might talk about the same thing, and you don't want to send the whole document to ChatGPT because this will be a lot of input tokens. But probably a certain paragraph is more relevant for the query of the user than others. So we want to be able to get just this paragraph. So what we are doing is we split up the document into paragraphs of a maximum length, and this can do this for us. There's also other document splitter implementations that you can have a look at. This is just the default here, and it's a good start. So when we have our ingester, then we need to use it to ingest documents. What I'm doing here is on every startup of the service, I go through the directory where I have these PDFs and I load them all into the Redis instance. In a real world service, you would rather, for example, listen to an update on the documentation and then fetch it again, or regularly update the documentation. But this is just for simplicity's sake. So what does this function do here? So it's pretty simple what it's doing. First, it's defining a parser. Here, LangChain offers us a couple of different parsers. In our example, we use the PDF document parser. However, there's also like a Office parser where you can parse Excel, PowerPoint, Word documents, and also stuff like CSV and so on. So what we do is we read all the files that end with .pdf from this directory, and for each of these PDFs, we get an input stream. We send this to the parser, so it's parsed. We get out a LangChain document, and then we ingest this document. There's also other overloads for this function where you can ingest multiple documents at the same time. So to sum it up, this documents loader, on every start of this service, it just goes through this directory, parses all the PDFs, and puts them into the ingester that will split the documents up according to this function and store them in our Redis. And that's all we need to configure to store the data in the Redis instance. Now we also need to retrieve the data. To do this, we need to define a documents retriever. The documents retriever, again, you can choose the name like you want it to be, needs to implement the retriever of text segment interface. It needs to be a bean, and as soon as it's a bean, Quarkus will pick it up and use it for your AI service. Again, we inject the embedding store and the embedding model into the constructor, and we define a retriever. Instead of the ingester, this time we defined a retriever from the store and the model, and we define how many results we want to have at most. This is an important parameter because this defines how many documents you will fetch and then send to ChatGPT in our case. Why is this so important? So when you fetch too few documents, then you might not get all the required context. But if you send too many of them, you might exceed the context of your model, or at least you will pay a lot more because you will fetch a lot of documents. In our case, if you remember, we ingested the documents and split them into 500 character at most. So when we now fetch 20 such documents, we will send up to 10,000 extra characters to ChatGPT. And so we will also have a lot more tokens on the input side, where ChatGPT is working with, but also where we are paying for. So optimizing this parameter can be quite important. Okay, now we did everything we need, and we will restart our Quarkus service so we can start ingesting the data. What we can see here is that Quarkus is already creating a new container instance. And then we see these logs here. This is currently still being logged. This are the vectors that Quarkus is importing. And then we see an ugly error here. When you see this error, that the connection pool reached the max weight queue size of 24, this is currently a problem where the ingester is putting too much stuff into Redis too quickly. But we can fix this easily by adding another property to the application properties. So we just increase the max pool weighting size to 128. So let's start again. So we see how Quarkus is importing the documents. And now we are finished and we can start using our service. So let's switch over to Postman again. And let's try this same query again. In the meantime, we can have a look at what Quarkus was sending. So we see the body here. Copy paste it over into our Scratch so we can format it. And now we see here the system message. That's the one from the annotation. And we see the user message, which starts with, how can I get started with Quarkus LangChain to call ChatGPT, which was my original prompt. But then additionally, we see here's some information that might be useful for answering. And then we see parts from the documentation. And this can then be used by ChatGPT to provide a better answer. So if we now have a look at the result from ChatGPT, we can see it is way more specific and includes the data it gained from the documentation documents that we put into it with the Retrieval Augmented Generation. For example, we see that it now tells us to use the OpenAI LangChain extension instead of just the generic REST client. Or that we can also use the Hugging Face extension to connect to Hugging Face models. It will also tell us about the environment variables that we need to provide to connect to the ChatGPT API, like the API key. For example, it will also tell us how you register an AI service and what you can configure here. So now the result from ChatGPT is very specific to our special content that ChatGPT has no idea about. And that's the power of Retrieval Augmented Generation. So we hope you've enjoyed this episode of our Quarkus series about LangChain and how you can use it to integrate with ChatGPT and Hugging Face. Please like and subscribe so you don't miss out on any of the future videos. In the next part of this series, we will talk about agents and how you can use ChatGPT to call functions in your Quarkus service to either retrieve data on demand or even perform actions like sending an email. So stay tuned and see you next time.